go yard. I got so much motherfucking design on right now.
Break it down, bring it back, make it clap. I got 3 old thoughts, new block, where that thing. Bitches on my line, and you know they come straight.
Uranic acid pathway is an alternative oxidative pathway for glucose and also known as glucuronic acid pathway. This process also including the synthesis of glucose to glucuronic acid, ascorbic acid, and pentose. In most of the carbohydrate metabolism phosphate, ester are participate, but in uranic acid pathway, free sugar or sugar acid are involved. Uranic acid pathway occur in liver and it doesn't lead to ATP generation, means there has no energy production.
Hi, my name is Nur Sabrina Nadia binti Muhammad Saini, and today I will be sharing about the biological importance of uranic acid pathway. Uranic acid pathway is one of the alternative way of glucose oxidation. And for your information, this pathway does not concern on the generation of energy, which means there is no ATP produced in this pathway even though glucose is oxidized. So, what is the importance of this pathway? The main importance of this pathway is to provide UDP glucuronic acid, which is the metabolically active form of glucuronic acid. This UDP glucuronic acid is involved in the synthesis of mucopolysaccharides, the conjugation of steroids, various drugs and toxins, and also the conjugation of bilirubin. This pathway is also important for the formation of pentoses and the formation of vitamin C in plants and animals, except men and guinea pigs. So that's all from me. Thank you.
Hi, I'm Nurul Aisha and will be presenting about synthesis of ascorbic acid. Well, in short, the uranic acid pathway is an alternative pathway for glucose oxidation leading to the formation of glucuronic acid and pentose sugar. Now, what does happen in this pathway actually? First of all, glucose get converted into a glucose 6-phosphate in the presence of enzyme glucokinase, and the ATP is split to produce ADP. Then the next step is reversible, in which glucose 6-phosphate is converted into glucose 1-phosphate in the presence of enzyme phosphoglucomutase. Next, glucose 1-phosphate is converted into UDP glucose, and in this step, the enzyme involved is UDP glucose phosphorylase, and the UDP is split to produce UDP. Next, UDP glucose is converted into UDP glucuronic acid, and the enzyme involved is UDPG dehydrogenase, and in this step, 2-NADH and 2 hydrogen ion combine to produce 2-NAD positive. Next, UDP glucuronic acid is converted into D-glucuronic acid, and the enzyme involved is UDP glucuronidase, and in this step, UDP is removed. Next, D-glucuronic acid is converted into L-gluconate, and the enzyme involved is glucuronate reductase, and in this step is also reversible, so that we can get an ADH and hydrogen ion from the ADP, and the reverse is also involved. Next, from D-gluconic acid, L-gluconate is produced, where they are basically different in lower animal and in human. What has happened in lower animal actually is that L-gluconate is converted into L-gluconolactone, and the water is removed in this process. Next is L-gluconolactone is converted to 2-L-gluconolactone in the presence of the enzyme gluconolactone oxidase. As you guys should know that this enzyme is actually deficient in human, so that this is the pathway forward to this reaction where they are not related or they are not involved. Next is 2-keto-L-gluconolactone is converted to ascorbic acid, but this is only involved in lower animal because they have the enzyme of gluconolactone oxidase, as the oxidase enzyme is not present in human. And that's why there is no formation of ascorbic acid in a human, but it can happen in pentose phosphate pathway that will be presented and explained by Shazrina in oxidation of L-gluconate.
I will present about oxidation of L-gluconate in uranic acid pathway. So the first step of the catabolism for glucuronic acid is reduction and catalyzed by glucuronic reductase. So L-gluconate will be oxidized by L-gluconate dehydrogenase to 3-keto-L-gluconate. NADH is used for energy in this reaction. And then 3-keto-L-gluconate will decarboxylase and form L-cellulose. One carbon from 3-keto-L-gluconate is released as carbon dioxide. So L-cellulose will reduce to xylitol by cellulose reductase. Oxidation occurs in xylitol by xylitol dehydrogenase and then produce D-cellulose. So D-cellulose is phosphorylated at carbon 5 to produce D-cellulose 5-phosphate. So this is the last compound that actually will metabolize further in pentose phosphate pathway.
Hi everyone, I am Sophia and I am going to explain about the metabolism reaction for uranic acid pathway. So this reaction started from glucose 6-phosphate, which is a combination of phosphorylation of glucose by hexokinase. This glucose 6-phosphate is isomerized to glucose 1-phosphate by phosphoglucomutase enzyme. Then, one UDP molecule is utilized in this reaction and glucose 1-phosphate will form UDP glucose catalyzed by UDP glucose pyrophosphorylase. Later in the reaction, from UDP glucose, there is a formation of UDP glucuronic acid and this reaction is catalyzed by UDP glucose dehydrogenase. UDP glucose is oxidized at carbon 6 by an AD-dependent UDP glucose dehydrogenase in a two-step reaction yield UDP glucuronate. Thus, we got UDP glucuronic acid, a molecule of an ADH and H+ ion as the final product.
Effect of drug on uranic acid pathway. Administration of drugs such as barbital and chlorobutanol significantly increases the uranic acid pathway to achieve more synthesis of glucuronate from glucose. This is because for detoxification of this drug, the glucuronate is required. Certain drugs like aminopyrin and antipyrin were found to enhance the synthesis of ascorbic acid in rats.
Hi, I am Nur Inshira and for this part, I am going to explain on the deficiency in uronic acid pathway. Essential pentosuria is a rare genetic disorder that occurs from the uronic acid pathway. This kind of disorder is due to the deficiency of the enzyme and ADP-dependent and xylitol dehydrogenase. These affected enzymes then causing the L-cellulose unable to be converted to xylitol. An example of its internal symptoms are individuals that were affected will excrete a large amounts of L-cellulose in urine and it gives a positive Benedict's test. But mostly, essential pentosuria is asymptomatic. Last but not least, essential pentosuria can be treated by using barbiturates or aminopyrin to help induce uranic acid pathway and increase the excretion of L-cellulose. That's all.